Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed the basic concepts and the equations of plane. Hope you have revised well. In today's session, we shall discuss problems from exercise 11.3. Let's move on to the topic. Before starting the session, let's recall the formulae of lines in a plane. The first one is point parallel form. Vector equation is vector r is equal to vector a plus lambda into vector b, and the Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here a, b, c are the direction ratios. Instead of direction ratios, if direction cosines are given, means a, b, c can be replaced by l, m and n. Next, 2-point form. Line passing through 2 points whose position vectors are a and b. Vector form is vector r is equal to vector a plus lambda into vector b minus vector a. And the Cartesian form, when x1, y1, z1 and x2, y2, z2 are the 2 points coordinates are given to you, means the formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Next, condition for two lines to be parallel, that is vector b1 is equal to lambda into vector b2, or a1 by a2 equal to b1 by b2 is equal to c1 by c2. Their direction ratios are proportional, that is in Cartesian equation form. Next, condition for two lines to be perpendicular, that is vector equation are given to you, means vector b1 dot vector b2 must be equal to 0. If the equations are in Cartesian form, the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. a1 a2 b1 b2 c1 c2 are the direction ratios. Instead of direction ratios, if direction cosines are given to you, means l1 l2 plus m1 m2 plus n1 n2 is equal to 0. Next, we learn about skew lines. Skew line means the lines which are neither parallel nor intersecting and they are lying in different planes or non-coplanar. Shortest distance between two skew lines we have learned, that is there we have studied modulus together we have used, but here I'm just keeping separately because it is easy for you to calculate. Then both are same only. Modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2, and the Cartesian form is determinant x2 minus x1 y2 minus y1 z2 minus z1 a1 b1 c1 a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. Next, we have learned about distance between, or the shortest distance between two parallel lines. There also we use the modulus together while studying, but here using separately, so it's not a problem, both are same. Which one is convenient, you can use it, that one. Here distance is modulus of b cross a2 minus a1 divided by modulus of b. So you have to by heart these formulas, and not only by hearting, you must be able to identify a1 b1 c1 a2 b2 c2. Then when equations are given to you like this form, that is r is equal to a plus lambda b means vector a and vector b, you must be able to identify. Then direction ratios and direction cosines, x1 y1 z1 x2 y2 z2, all these things you must know how to identify from the equations. Next, we shall bring the formulae for planes under one frame. First one we have learned, that is normal form. Vector equation is vector r dot unit vector n is equal to d, and the Cartesian equation is lx plus my plus nz is equal to d. Next one we have learned point normal form, that is vector form vector r minus vector a dot vector n is equal to 0. Cartesian form is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Next one, equation of a plane passing through three non-collinear points. The vector form is vector r minus vector a dot vector b minus vector a cross vector c minus vector a equal to 0. And the Cartesian form is determinant x minus x1 y minus y1 z minus z1 x2 minus x1 y2 minus y1 z2 minus z1 x3 minus x1 y3 minus y1 z3 minus z1 is equal to 0. Next is intercept form. plane cutting off intercepts A, B and C from X, Y and Z axis is X by A plus Y by B plus Z by C is equal to 1. Next one is plane through intersection of two planes. That is vector r dot vector n minus d1 plus lambda into vector r dot vector n2 minus d2 is equal to 0. This is the vector form, and the Cartesian form is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. Next, condition for two planes to be parallel. When it is in vector form, vector n1 cross vector n2 is equal to 0 vector, or vector n1 is equal to lambda into vector n2. If it is in Cartesian form, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Next one is condition for two planes to be perpendicular. In vector form, vector n1 dot vector n2 is equal to 0. In Cartesian form, a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Next condition for a line and a plane to be parallel. Vector n1 dot vector n2 is equal to 0. And a1 a2 plus b1 b2 plus c1 c2 is equal to 0. This is for Cartesian form. And here these two conditions are same. Condition for two planes to be perpendicular and a condition for a line and a plane to be parallel. Both are same condition. Next one is condition for a line and a plane to be perpendicular. That is vector n1 cross vector n2 is equal to 0 vector, or vector n1 is equal to lambda into vector n2, or else a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here also condition for two planes to be parallel and a condition for a line and a plane to be perpendicular. Both are same conditions. Then next one, condition for two lines to be coplanar. The condition is vector a2 minus vector a1 dot vector b1 cross vector b2 is equal to 0. This is the vector form. And if it is in Cartesian form, determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 is equal to 0. Next, distance between a point and a plane. Vector form is modulus of vector a dot vector n minus d divided by modulus of vector n. And the Cartesian form is ax1 modulus of ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This formula also can be used to find the length of the perpendicular from a particular point to the plane. Move on to exercise questions. Exercise 11.3, first question. The question is, in each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. We are asked to calculate the direction cosines of the normal and the distance from the origin. First equation is z is equal to 2. First of all, we have to write this one in standard form, that is 0x plus 0y plus z is equal to 2. Label it as equation number 1. We have learned while learning the basics of plane, general equation of plane is ax plus by plus cz plus d is equal to 0. In some textbooks it is using small a, small b, small c and small d. It's not a problem, anyone you can use. A, b, c and d are here I am using capital letters. Here ax plus by plus cz plus d is equal to 0 is the general form, and a, b and c are the direction ratios of the normal to the plane. A, B and C are the direction ratios of the normal to the plane. And again we have learned the normal form of equation of plane. In Cartesian form we can write it as Lx plus My plus Nz is equal to D. Here L, M and N are the direction cosines and D is the distance of the plane from the origin. These are all we have learned in the previous lesson. L, M and N are the direction cosines and D is the distance from the origin. And here A, B and C are the direction ratios. While learning vectors chapter, we have learned there direction ratios are given to you means how to find out the direction cosines. It is quite simple. There what we have done is we have divided the vector by its magnitude. Then we will get the direction cosines. Here also somewhat similar only. First of all, we have to write the direction ratios of the normal, that is 0, 0 and 1. and next we have to go for squares, sum of the squares and then its square root, that is a root of 0 square plus 0 square plus 1 square. We have calculated the value, we have got as 1. Now just divide both sides of the equation number 1 by 1. This is equation number 1, we are dividing it throughout this equation number 1 by this 1. Then we will get it as 0 by 1 is 0, so 0 into x. Again here 0 by 1 is 0, 0 into y. Then here 1 by 1 is 1, so 1 into z is equal to 2. This one is similar to Lx plus My plus Nz is equal to d, because we have already divided with this quantity. Then we have to compare it, this one with Lx plus My plus Nz is equal to d. We will get L is equal to 0, M is equal to 0, N is equal to 1 and D is equal to 2. Move on to second part, the x plus y plus z is equal to 1. The process is similar to the previous one. Just first we have to write the direction ratios of normal. This is already in standard form, so no need to convert. So just we have to write the direction ratios of normal 1, 1 and 1 is written. Calculate the square root of 1 square plus 1 square plus 1 square, sum of the squares of these direction ratios. We will get as a root 3. Then we have to divide both sides of equation number 1 by root 3. This is equation number 1, we have divided with the root 3. Then we will get as 1 by root 3 into x plus 1 by root 3 into y plus 1 by root 3 into z is equal to 1 by root 3. Both sides we are dividing. Then as before we have to compare with Lx plus My plus Nz is equal to d. L is equal to 1 by root 3, M is equal to 1 by root 3, N is equal to 1 by root 3 and D is equal to 1 by root 3. Move on to question number 2. The question is, find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector 3i cap plus 5j cap minus 6k cap. Go through the question and identify the given conditions. Here distance is given to you, that is 7 units. Distance means d is given 7 units and a normal vector is given, that is 3i plus 5j minus 6k. So let's write down the given conditions. Vector n vector, normal vector is given. Remember, this is a normal vector, not a unit vector. So n vector is 3i cap plus 5j cap minus 6k cap. And d is also given, d is equal to 7 units. And we know the vector form, that is r dot n cap is equal to d. Vector r dot n cap is equal to d. Here vector n is there, we have to find out n cap for writing the vector equation. So let's write the normal vector n. Vector n is equal to 3i cap plus 5j cap minus 6k cap. So we have to go for writing down the vector n cap. We know the formula, n divided by modulus of n. Vector n divided by modulus of vector n, that is equal to modulus of vector n means we know root of x square plus y square plus z square, that is 3 square plus 5 square plus 6 square, that is a root of 3 square plus 5 square plus 6 square in the denominator, and the numerator is vector n itself, that is 3i cap plus 5j cap minus 6k cap, that is equal to, numerator is same, denominator 3 square is 9, then 5 square is 25, 6 square is 36. When you add these 3, we will get as 70, root of 70. So the equation of the plane with position vector r is given by vector r dot n cap is equal to d. This is a vector form because it is asked to write vector equation. So vector r dot n cap is equal to d. Let's substitute it. That is vector r. R is the general vector, so let it be there. R dot 3i cap plus 5j cap minus 6k cap divided by root 70, that is our n cap, is equal to d. Distance we have already written here, that is equal to 7. So this is the vector equation of the plane. Move on to question number 3. The question is, find the Cartesian equation of the following planes. First equation, vector r dot I cap plus j cap minus k cap is equal to 2. Here vector r dot I cap plus j cap minus k cap is equal to 2. Vector r, it is quite familiar for us. We have used this vector r while deriving the plane equations. Vector r means it is a position vector of an arbitrary point P on the plane. There we have taken vector r as xi plus yj plus zk because the arbitrary point we have taken as xyz. So same method here also we are going to use. Label it as equation number 1. For any arbitrary point P xyz on the plane, position vector r is given by xi plus yj plus zk. So what we are going to do is just substitute xi plus yj plus zk for vector r, then go for the dot product. You will get the Cartesian equation. That is the easy way. So substituting in equation number 1, this vector r is replaced by xi plus yj plus zk dot, the balance is same, I cap plus j cap minus k cap is equal to 2. We know how to take the dot product of two vectors. Just to multiply the components, that is enough. So I and I components, if you take x and here 1, x into 1 is x itself, then here y and 1, so y into 1 is y, and z and minus 1, that is minus z. So the answer will be x plus y minus z is equal to 2. So this is the Cartesian equation of first question. Then question number B, vector r dot 2 I cap plus 3 j cap minus 4 k cap is equal to 1. Same as the previous question. Label it as equation number 1 and let's take r as xi plus yj plus zk. Then just substitute it in equation number 1. Equation number 1 is r dot 2 I cap plus 3 j cap minus 4 k cap is equal to 1. Instead of vector r, we are just using xi plus yj plus zk dot 2 I cap plus 3 j cap minus 4 k cap is equal to 1. When you take the dot product, x into 2, that is 2x, y into 3, that is 3y, z into 4, that is 4z equal to 1. So 2x plus 3y minus 4z is equal to 1. This is the Cartesian equation of the given plane. Next we shall discuss question number 4. Question is, in the following cases, find the coordinates of the foot of the perpendicular drawn from the origin. We are asked to find out the coordinates of the foot of the perpendicular. We have already learned the formula for finding the foot of the perpendicular. Here the plane is given 2x plus 3y plus 4z minus 12 is equal to 0. The formula for finding the foot of the perpendicular is LD, MD, ND. These are the coordinates LD, MD and ND. Here L, M and N are the direction cosines of the normal to the plane and D is the distance from the origin. Here equation of plane is given to you. From here we have to calculate L, M and N, and also we have to find out D. So for that purpose, first of all we have to write equation in ax plus by plus cz is equal to D form. Here 2x plus 3y plus 4z is equal to D. This one we have to bring to the right side. Then we have to go for finding the direction cosines. We have already learned this one in first question. What we have to do is, first of all we have to write the direction ratios. 2, 3 and 4 are the direction ratios. And then we have to go for finding the square root of the sum of the squares of the direction ratios, that is root of 2 square plus 3 square plus 4 square, that we have calculated. Then 2 square is 4, then 3 square is 9, 4 square is 16. When we add this, we will get a root of 29. Next process is just to divide this root 29 in equation number 1, both sides of the equation number 1. So dividing both sides of equation 1 by root 29, 2 divided by root 29 into x plus 3 divided by root 29 into y plus 4 divided by root 29 into z is equal to 12 divided by root 29. Here we have to compare it with lx plus my plus nz is equal to d. Then we will get L is equal to 2 by root 29, m is equal to 3 by root 29, n is equal to 4 by root 29 and d is equal to 12 by root 29. Now we can use this formula to calculate the foot of the perpendicular because we have got L, M, N and D. So when you write the coordinates of the foot of the perpendicular, L is 2 by root 29 into D is 12 by root 29. It is calculated, comma, then 3 by root 29, that is M, 3 by root 29 into D is 12 by root 29, comma, N is here 4 by root 29 into D is 12 by root 29. Go for calculation, that is 2 into 12, that is 24, root 29 to root 29 is 29, 3 into 12, that is 36, divided by root 29 into root 29 is 29, 4 into 12, that is 48, divided by root 29 to root 29 is 29. So 24 by 29, 36 by 29 and 48 by 29. This is the coordinates of the foot of the perpendicular of the given plane. Then question number B, 3y plus 4z minus 6 is equal to 0. As before, let's write it in standard form. Here x coordinate is not there, so let's write with 0. 0x plus 3y plus 4z is equal to minus 6. We have to bring to the right side, that is plus 6. Equation number 1. Then the direction ratios we can write 0, 3 and 4. Then square root of 0 square plus 3 square plus 4 square. So 0 square is 0, 3 square is 9, plus 4 square is 16. So 9 plus 16 is 25, root 25 value is 5. So let's divide it by 5. Then 0 by 5 into x, that is 0x. Then 3 by 5 into y, that is 3 by 5y. Then 4 by z into a. 4 by 5 into z is equal to, here 6 is right side. So 6 divided by 5. We are dividing both sides of equation number 1 by 5. Then we can compare it with Lx plus My plus Nz is equal to D. We will get L is equal to 0, M is equal to 3 by 5, N is equal to 4 by 5, and finally D is equal to 6 by 5. Then L, M, N and D we have got. So we can use LD, MD and ND formula for finding the coordinates of the foot of the perpendicular. So LD, MD, ND implies, let's substitute it, 0 into 6 by 5, that is L into D, then M 3 by 5 into 6 by 5, then N into D 4 by 5 into 6 by 5. It's written. Go for calculation, that is 0 into 6 by 5 is 0, 6 into 3 is 18, by 5 into 5 is 25, 4 into 6 is 24, by 5 into 5 is 25. So 24 divided by 25. So this is the foot of the perpendicular of the given plane. 3y plus 4z minus 6 is equal to 0. Next we shall discuss question number 5. Question is, find the vector and Cartesian equation of the planes. First question, that passes through the point 1, 0, minus 2 and the normal to the plane is I cap plus j cap minus k cap. First of all, you have to go through the question and you have to identify in which form the question is asked. Here a passing through point is given and a normal vector is also given. A passing through point and a normal vector is given to you means it is point normal form. The vector equation is vector r minus vector a dot vector n is equal to 0. Here vector r is the position vector of an arbitrary point. Vector a is the position vector of the given point and vector n is the normal vector. Here let's write the position vector of the point, that is 1, 0, minus 2. Here x coordinate is 1, y coordinate is 0 and z coordinate is minus 2. Since x coordinate is 1, we will write as I cap. Y coordinate is 0, so there is no j cap, and here z coordinate is minus 2, so we will write as minus 2 k cap. Here position vector, vector a is I cap minus 2 k cap. Then the normal vector is given, that is I cap plus j cap minus k cap. Let's substitute in the equation, that is vector r minus vector a dot vector n is equal to 0. As I said before, r we will keep the same and a and n we will substitute. That is vector r minus a vector is I cap minus 2 k cap dot vector n is I cap plus j cap minus k cap equal to 0. No more for the simplification. We will keep it the equation as same and label it as equation number 1. Next we have to go for finding the Cartesian equation. For Cartesian equation we are not going to use any separate formula, just we will substitute this value of vector r in Cartesian form. Vector R, we know that it is a position vector of the arbitrary point x, y, z. That is, when you write in vector form, it comes as xi plus yj plus zk. So let's substitute it. That is xi plus yj plus zk minus, this one is I cap minus 2k cap, it is same, dot I cap plus j cap minus k cap is equal to 0. This one we have got by substituting the value of vector r in equation number 1. Then little bit of calculation inside the bracket, that is here xi, here minus I. When we take I cap outside, x minus 1 into I cap plus here y j cap is there, but here there is no j cap. So y j cap remains the same, plus here z k cap and here minus 2 k cap. So when we write it is this minus sign comes inside, it comes as minus into minus plus 2. So z plus 2 into k cap dot outside is same I cap plus j cap minus k cap is equal to 0. So we have to find out the dot product of these two vectors. We know that just multiply the scalar components, that is here x minus 1 and here 1, here y and here 1, and here is z plus 2, here minus 1. That is x minus 1 plus y minus z plus 2. Minus z plus 2 how comes in the sense, here is z plus 2, here minus 1. When we multiply, minus z plus 2 equal to 0. Little bit of simplification, that is x plus y minus z, x plus y minus z is equal to, here there is minus 1 and here there is minus 2. Minus into plus is minus, so minus 2. Minus 1 minus 2 is minus 3 equal to 0. So we can take this minus 3 on right side, that is x plus y minus z is equal to 3. This is the Cartesian equation of the given question. Next we shall discuss question number 6. Question is, find the equations of the plane that passes through the points 1, 1, minus 1, 6, 4, minus 5, minus 4, minus 2, 3. So 3 points are given to you. So here we have to identify the formula first, that is the equation of the plane passing through the points x1, y1, z1, x2, y2, z2 and x3, y3, z3 is given by determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Provided these 3 points must be non-collinear points, means there should not be lying in same line. So first of all, we have to check the collinearity of these 3 points. For that, we have already learned we have to take the determinant form of these 3 points. That is, we have to consider the points as A, B and C. Then we have to find out the determinant value, that is 1, 1, minus 1 we have to write in first row. Next 6, 4, minus 5 we have to write in second row. Minus 4, minus 2, 3 we have to write in third row. If this determinant value gets 0, then these 3 points are collinear. Then we cannot use this formula. If this determinant value is non-zero, then only we can substitute in this equation. So let's find out the value of this determinant, that is 1 into, that row and column is gone, 4 into 3 is 12. Here minus into minus plus, already again formula there is a minus, so 3 minus means resultant will be minus, so 5 into 2 is 10. So 12 minus 10, 1 is outside, so since 1 into any quantity, the same quantity itself, so we are not going to write that 1. Then 1 into, minus 1 into, here minus sign, 1 we are not writing, that row and column is gone. 6 into 3 is 18, then 3 minus will be coming here, then resultant will be minus 20. So 18 minus 20, again actual sign is plus here, but here there is a minus 1, so we have to put minus here. That row and column is gone. 6 into minus 2, that is minus 12, and minus into minus plus, 4 into 4 is 16. Then we will get as 12 minus 10, that is 2, 18 minus 20 again 2, minus 12 plus 16, minus 12 plus 16 is 4, so minus is outside, so minus 4. Here 2 plus 2 is 4, 4 minus 4 is 0, so we have got the value of the determinant 0, means A, B, C are collinear points. So we cannot form an equation by using this formula, and we have to write the conclusion as there will be infinite number of planes passing through the given points. Since the points are collinear, they are in a same straight line, so there will be infinite number of planes passing through the given points. That we have to write as conclusion. Next we shall discuss the B part. 3 points are given to you: 1 1 0, 1 2 1, minus 2 2, minus 1. So let's take these points are A, B and C. Then we have to check whether these points are collinear or not. First we have to check the collinearity of these 3 points. If they are collinear, then there will be infinite number of planes will be passing through these 3 points. If they are non-collinear, then there will be a unique plane, a single plane that will be passing through this A, B and C. So here let's take the determinant, that is first point will come as first row, second point will come as second row, third point will come as third row. Let's find out the value of this determinant. 1 into row and column is gone, 2 into minus 1, that is minus 2, again 2 into 1 is 2, so minus 2. Minus 1 into that row and column is gone, 1 into minus 1, that is minus 1, minus into minus plus, 2 into 1 is 2. Let's calculate, that is minus 2 minus 2, minus 4, minus 4 into 1 is minus 4, minus 1 plus 2, that is 1. So 1 into minus 1, again minus 1. So minus 4 minus 1 is minus 5, that is a non-zero number, that is not equal to 0. Therefore, we can say that a plane will pass through the point ABC. A plane means a unique plane will pass through the point A, B and C. Let's write the formula. The equation of the plane through the points x1, y1, z1, x2, y2, z2 and x3, y3, z3 is given by determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Let's substitute it. Here determinant x minus x1, the first point is x1, y1, z1, second point x2, y2, z2, x3, y3, z3. So x minus x1 is x minus 1, then y minus y1, y minus y1 is 1, so y minus 1, z minus z1, that is z minus 0, z minus 0 is z. Then x2 minus x1, x2 is here, x2 minus x1 is 1 minus 1, 1 minus 1 is 0. y2 minus y1, 2 minus 1, 2 minus 1 is 1. Next is z2 minus z1, z2 is 1, here z1 is 0, 1 minus 0, 1 minus 0 is 1. Next is x3 minus x1, x3 is minus 2, then x1 is 1, minus 2 minus 1, that is minus 3. y3 minus y1, y3 is 2 and here y1 is 1, so 2 minus 1 is 1. Next is minus 1 minus 0, minus 1 minus 0 is minus 1, that is equal to 0. Next let's expand it. X minus 1 into that row and column is gone, 1 into minus 1, that is minus 1, again 1 into 1 minus 1, minus second term, that is y minus 1, that row and column is gone, 0 into minus 1, that is 0, then that row and column it is deleted, then 0 into minus 1, that is 0, then minus into minus plus, 3 into 1 is 3, 0 plus 3, plus third term, that is z into that row and column is gone, 0 into 1 is 1, sorry 0 into 1 is 0, minus into minus plus, 3 into 1 is 3, so we will get a 0 plus 3 equal to 0. Let's go for calculation. That is x minus 1 into minus 1 minus 1, that is minus 2, again y minus 1 into 0 plus 3, that is 3, z into 0 plus 3 is 3 equal to 0. That is, remove the bracket, minus 2 into x, minus 2x, minus into minus plus, 2 into 1 is 2, then here minus is there, y into 3, that is minus 3y, minus into minus plus, 1 into 3 is 3, then plus 3z is equal to 0. Here minus 2x minus 3y plus 3z is equal to, here there is 2 plus 3, 2 plus 3 is 5, then we are taking that 5 to the right side, that becomes minus 5. There is a minus common here, let's cancel it, that is 2x plus 3y minus 3z is equal to 5. This is the required equation of the plane passing through the 3 given points. Next, we shall discuss question number 7. The question is, find the intercepts cut off by the plane 2x plus y minus z is equal to 5. Here, we are asked to calculate the intercepts cut off by the plane 2x plus y minus z is equal to 5. Let's recall the intercept form. The equation of the plane in intercept form is x by a plus y by b plus z by c is equal to 1. Here, a, b and c are the intercepts cut off by the plane x, y and z axis respectively. A, b, c are the intercepts. Here, when you observe this equation, it is quite clear. On the right side 1 and here on the left side coefficient of x, y and z is 1. So that is the standard form we have to make it. Given equation we have to write 2x plus y minus z is equal to 5. Right side, first of all, we have to make it 5. For that, dividing both sides of the equation by 5, we will get as 2 by 5 into x plus y by 5 minus z by 5 is equal to 5 by 5 is 1. Now we have to see here again x, y and z coefficients we have to make 1. Here y and z is okay, but here when you check x, it is 2 is the coefficient. 2 by 5 is the coefficient. Of course, numerator is 2. So we have to go for a little bit of rearrangement, that is x divided by this 2 by 5 we can write as denominator 5 by 2 plus here is no problem y by 5. Here little bit of adjustment because we need a plus here. So plus means just to bring that minus to the denominator, that is z by minus 5 equal to 1. Now it is in standard form. Once again, here coefficient of x is 2 by 5, but we need here coefficient of x 1. Quite simple, just x divided by this 2 by 5 we can write it as a reciprocal, that is 5 by 2 plus here okay y by 5 same. Here there is a minus sign, we don't want that minus, just to bring to the denominator. So plus z by minus 5 is equal to 1. Now this is in the form x by a plus y by b plus z by c is equal to 1. You have to compare it with the standard equation. Then we can write a is equal to here 5 by 2 and b is equal to 5 and c is equal to minus 5. So these are the intercepts a, b and c. We have got as 5 by 2, 5 and minus 5. Next, we shall discuss question number 8. Question is, find the equation of the plane with intercept 3 on the y-axis and parallel to z-x plane. Given condition is intercept 3 on the y-axis, that is y-intercept is 3 and parallel to z-x plane. Let's visualize the question. So here y-intercept is 3, means x-coordinate and z-coordinate is 0. So the coordinates are 0, 3, 0. And it is parallel to z-x plane. Z-x plane means this is the z-x plane, and here the given plane is parallel to this z-x plane. We are asked to find out the equation of the plane. Here the equation of the plane z-x plane equation is y equal to 0. Z-o-x plane is this one, and here there is no y value, so y is equal to 0 is the equation of the z-x plane. Next, any plane parallel to z-x plane is of the form y is equal to a. Any plane parallel to z-x plane. Parallel to z-x plane means somewhat similar to the given plane. This is the one. Parallel to z-x plane means it is y is equal to a constant. So that is the general equation of a plane parallel to z-x plane. Only y-intercept will be there. Y is equal to a constant. Here y-intercept is given to us, that is 3. Y-intercept is 3, that is a. Here y is equal to a is the equation, a is equal to 3. Let's substitute it. Hence the equation of the required plane is y is equal to 3. Next we shall discuss question number 9. The question is, find the equation of the plane through the intersection of the planes 3x minus y plus 2z minus 4 is equal to 0. And x plus y plus z minus 2 is equal to 0 and the point 2, 2, 1. We are asked to find out the equation of the plane passing through the intersection of these two planes and passing through point 2, 2, 1. We have already learned the formula for finding the equation of a plane passing through the intersection of two planes is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 equal to 0. This is a Cartesian form because the given equations are in Cartesian form. This is plane 1 plus lambda into plane 2. P1 plus lambda into P2. This is a short form to recall this formula. Plane 1 equation plus lambda into plane 2 equation is equal to 0. The equation of the given plane through the intersection of the planes 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2 is equal to 0 is given by, let's write by using this formula, plane 1 equation, that is 3x minus y plus 2z minus 4 plus lambda into plane 2 equation, x plus y plus z minus 2 is equal to 0. One condition also given to us, that is this plane is passing through 2, 2, 1. Means this equation or the plane, given plane, the required plane is passing through this equation, this point 2, 2, 1. Means this point will satisfy this equation. Satisfy this equation in the sense when you replace x, y and z and put 2, 2, 1, we will get the value 0. So let's write it this one as equation number 1. This plane passes through the point 2, 2, 1. Therefore, this point will satisfy equation number 1. This point in the sense 2, 2, 1. So let's substitute these points to equation number 1. 3x minus y plus 2z minus 4 plus lambda into x plus y plus z minus 2 equal to 0. When we replace x, y and z and we put 2, 2 and 1. Here x is replaced by 2, y is 2 itself, and z is replaced by 1 minus 4 plus lambda into, as before, x is replaced by 2, y is replaced by 2, z is 1, minus 2 equal to 0. Go for the calculation, that is 2 plus 3 lambda. Here when you check 3 into 2 is 6, 6 minus 2 is 4, 4 and minus 4 is 0, so only 2 into 1 balance, 2 into 1 is 2. Here inside if we check plus 2 minus 2 cancel, 2 plus 1 is 3 lambda equal to 0. So that is lambda is equal to plus 2 will go to the right side, that is minus 2 divided by 3. Lambda we have got. If you substitute the value of lambda in equation number 1, we will get the required equation. That's all. Here substituting in 1, 3x minus y plus 2z minus 4 minus lambda. Lambda is replaced plus lambda. So here it is minus 2 by 3 is the value of lambda. Just we substituted minus 2 by 3 into x plus y plus z minus 2 is equal to 0. Go for calculation. Here denominator is 3. Let's take it as common denominator. Means this 3 we have to multiply here. And common denominator 3 will multiply with this right side 0 by cross multiplication. So the denominator will come to the right side as 0. That is here 3 multiplying in the sense 3 into 3x minus y plus 2z minus 4 minus 2 into x plus y plus z minus 2 is equal to, there was a common denominator 3, that 3 multiplied with this 0 cross multiplication, so it becomes 0. That is 3 into 3 9x, 3 into y 3y, 3 into 2 6z, 3 into 4 12 minus 2 into x plus y plus z minus 2 is equal to 0. Then go for calculation, simplification. 9x minus 2x is 7x, minus 3y minus 2y, that is minus 5y, 6z minus 2z, that is 4z, minus 12, minus into minus plus 2, that is minus 8 equal to 0. So 7x minus 5y plus 4z minus 8 is equal to 0. This is the equation of the required. Next we shall discuss question number 10. The question is, find the vector equation of the plane passing through the intersection of the planes. Vector r dot 2i cap plus 2j cap minus 3k cap is equal to 7. Again vector r dot 2i cap plus 5j cap plus 3k cap is equal to 9, and through the point 2, 1, 3. Here two vector equations are given to us. In the previous question we have got two Cartesian equations and a passing through point. Here two vector equations and a passing through point is given. Here let's recall the formula in vector form, that is plane 1 plus lambda into plane 2 is equal to 0. That is r dot n n1 minus d1 plus lambda into vector r dot vector n2 minus d2 equal to 0. How to recall in the sense plane 1 plus lambda into plane 2, p1 plus lambda into p2 equal to 0. Equation of the required plane is given by, just write the first equation, that is plane 1 equation, vector r dot 2i cap plus 2j cap minus 3k cap, this plus 7 bring to the left side, that is minus 7, plus lambda into plane 2 equation, that is r dot 2i cap plus 5j cap plus 3k cap minus 9 equal to 0. Little bit of rearrangement we have to do. Here there is vector r, here also vector r. Let's take common vector r into, here there is 2i cap plus 2j cap minus 3k cap balance plus lambda into, here lambda into 2i cap plus 5j cap plus 3k cap is the balance. So r, vector r I have taken outside. Here balance is this term, it is written. Here balance is lambda into this term. Then here there is a minus 7 balance. This minus 7 will come to the right side as plus 7. And here there is minus 9 into lambda. That is minus 9 lambda is there. That will come to the right side as plus 9 lambda. Then calculation part, r dot. Here 2 I cap and here 2 lambda I cap. Let's take the scalar components out. That is 2 plus 2 lambda into I cap plus, here there is a 2 and here there is 5 lambda. So 2 plus 5 lambda into j cap. Here there is minus 3 and here there is 3 lambda. So let's take the positive term first. That is 3 lambda minus 3 into k cap equal to 9 lambda plus 7. Let's take it as equation number 1. The plane passes through the point. This plane is passing through the point 2, 1, 3. In the previous question, what we have done is, we have taken this one as x, y and z, and since the given equation was in Cartesian form, we replaced that equation and substituted for x, y and z the given points. Then we found the value of lambda. But here it is in vector form. What we have to do is, by using these 3 points, we have to write the position vector r. So let's write that one. The position vector is given by vector r is equal to 2i cap plus j cap plus 3k cap. Then we have to substitute this one in equation number 1. Let's substitute in equation number 1. So r becomes 2i cap plus j cap plus 3k cap. The balance is same. 2 plus 2 lambda into I plus 2 plus 5 lambda into j cap plus 3 lambda minus 3 into k cap is equal to 9 lambda plus 7. Dot product of two vectors. So just to multiply the component, scalar components, that is 2 into 2 plus 2 lambda plus 1 into 2 plus 5 lambda plus 3 into 3 lambda minus 3 is equal to 9 lambda plus 7. That is 2 into 2 is 4. Then again 2 into 2 4 lambda, 1 into 2 is 2, 1 into 5 lambda is 5 lambda, 3 into 3 9 lambda, again 3 into 3 is minus 9 is equal to 9 lambda plus 7. Here 4 lambda plus 5 lambda, 9 lambda plus again 9 lambda, that is 18 lambda. 4 plus 2 is 6, 6 minus 9 is minus 3 equal to 9 lambda plus 7. Then 9 lambda, here 18 lambda is there, this 9 lambda will come to the left side, that is minus 9 lambda. So 18 lambda minus 9 lambda is 9 lambda. Here there is a 7 on right side, this minus 3 will go to the right side, it becomes plus 3. So 7 plus 3 is 10. And here lambda is equal to 10 divided by 9. So we have got the value of lambda. As before, let's substitute it in equation number 1. That is r dot 2 plus this 2 lambda. We have to replace. So 2 into lambda value is 10 by 9 plus I cap, into I cap plus 2 plus 5 lambda. Lambda we have to replace and substitute 10 by 9 into j cap plus 3 lambda. 3 lambda means 3 into lambda value is 10 by 9 minus 3 into k cap. It's written is equal to 9 lambda plus 7. Again lambda replaced, 9 into lambda. Lambda is 10 by 9. 9 into 10 by 9 plus 7. That is, here 9 into 2 is 18. 18 plus 20, that is 38 by 9 into I cap. Here when you check 9 into 2 18, 18 plus 50, that is 68 by 9 plus here 9 into 3, 20 is 7. So 30 minus 27 is 3. 3 by 9 into a cap is equal to, here 9 cancel, 10 plus 7, that is 17. Then after doing calculation, this 9 we have taken as common LCM and this 9 we have multiplied here along with 17. So we will get the answer as R dot 38 I cap plus 68 J cap plus 3 K cap is equal to 17 into 9, that is 153. So this is the required equation of the plane. Dear students, today we have discussed first 10 questions from exercise 11.3. I request all the students to go through the video and solve these 10 questions independently. And while solving, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.